Good morning and welcome back to Litmus Test. We're getting a very early start this morning because today we're going to talk about a couple of things. We're going to talk about spontaneity, activation energy, exo and endothermic. All of these are important words that mean lots of things, and to talk about this we're going to want to move a little bit away from the base, just for aesthetic reasons. But while we talk, the first thing I'm going to say here about these terms are that exo and endothermic are well defined in one of my other videos. It's an older video using the volts mod pack, and you can probably find it without too much trouble looking through the old videos. It's a bit off on the the sound, but you should be able to get most of the idea. And it has the volts mod pack had a few more things in it than my stuff does now, but or that this mod pack does, that really helps show that idea. Some bone. Who knew that was here, right? Anyways, gosh, that was a long, rambly thing. Let's talk about some words while we travel. So, spontaneous, or spontaneity, which is the property of being spontaneous. Everyone sort of knows spontaneous means, you just do stuff on your own. Well, that's the same in chemistry, that spontaneous means something that happens sort of on its own, or more precisely, once something starts happening, it continues to happen without any additional work being required. So it just sort of starts happening, and then it just keeps going. There's a lot of things that are spontaneous. In fact, most things that we see happening are well, they appear spontaneous. Most of them are not actually spontaneous. Like, for example, when this chicken lays an egg, that looks like it's spontaneous to us, but it did require work, and if the chicken stops, or the chicken's body stops putting work into it, then nothing will happen from that. It's, well, if you consider the process of an egg growing up into a chick, it looks like a spontaneous thing. There's a chick for us. And in Minecraft it kind of is, but notice that Minecraft has to continue taking that timer, and that chickens have to eat and grow, etc., for them to actually grow. So even though it looks spontaneous, even that is not quite spontaneous. Growth in general, biology, is not spontaneous. It requires work. Spontaneous things do not require work. They just start and keep going. But don't confuse this with activation energy. Let's have we're far enough out here, I think we can have some examples. So I can light a fire, right? And that lighting of the fire wasn't exactly spontaneous, but now that it's lit, it keeps going. It took me a little bit of activation energy to get it started. It took some activation, it took a little bit of energy to start, but once started, it is going on its own. Additionally, if we come over here, very dangerously light something on fire, good thing this is an alpha, right? Then spontaneously, the fire will maybe travel across, maybe. The fire generally, if this was alpha, would travel, there it goes, to other parts of the tree and nearby stuff. This, of course, happens very easily when you have lava just sitting around, but we all know it happens with fire too. It took activation energy to start the fire. I had to click to start it. But once started, it just goes on its own. It is spontaneous, yet it requires activation energy to start. Every chemical reaction requires some activation energy, whether or not it is spontaneous. So, the chemical reactions that produce a blueberry, or the reactions that help you metabolize a blueberry, require some activation energy, whether or not they're spontaneous. Another example of this is here with this TNT, right? So we know that this TNT, it takes some activation energy to start, but once started, that explosion is spontaneous. There is no work required for that explosion to continue. That just happened all on its own, and look, it found us some osmium. How nice. So spontaneity is whether something happens and does not require work to keep happening, like this fire, but activation energy is just the amount of energy needed to start something, and all reactions have some activation energy, whether or not they are spontaneous, like fire, or not spontaneous, like growth of living things. To continue on with this idea of fire, let's put down a furnace and discuss cooking. So if we take this pig and light him, that's not a pig. Well, you know. Come here. So generally, when we cook meat, we consider this to be an exothermic thing. This is a reaction that gives off heat. It gave off heat, and you'll notice in our survival inventory produced cooked mutton because it was on fire when we killed it. We think of that as an exothermic reaction, but this raw pork chop, when I stick this out in here and I start cooking it, think about the system differently. Instead of thinking about the system as being the furnace, which is, or the coal, which is on fire, yeah, the burning of the coal is exothermic, but the cooking of the pork chop, energy has to go into the pork chop. We have to release energy from the charcoal to go into the pork chop. That's endothermic. And all cooking is, in that sense, endothermic. It's something that absorbs heat. We think of endothermic reactions usually as something that's like cold, like an ice pack, but really all cooking is endothermic, and a lot of chemistry is endothermic as well. Any reaction that you need to keep going with a fire or some sort of heating element or anything you need to reflux or boil, that's because your reaction is endothermic, like this cooking of the pork chop. Now, of course, producing that heat is exothermic. So producing some heat here, yeah, that's well, that's exothermic, but the meat that is cooked from this will have been cooked because cooking is an endothermic process. Endothermic processes. So, exothermic reactions are reactions that produce heat, like burning, but endothermic reactions, like the Maillard reaction, that is responsible for cooking, that makes this beautiful brown color, makes all the taste. All of cooking reactions and a lot of chemical reactions are actually endothermic. They absorb energy. And that's our vocabulary for the day. Go back, look through some of my other videos on exo and endothermic, and let's see, and take a look at some other examples of exo and endothermic, and then remember that spontaneous and the other word, activation energy, that's the one, thank you, me. Spontaneous and activation energy, things that I think actually I also have videos on, but spontaneous is something that once it's started, it keeps going, it doesn't need work, and activation energy is just the energy needed to start or activate the reaction. It's not the same as spontaneous. The text got cut off right there. Exo and endothermic, a reaction or process that gives off heat or absorbs heat, even though cooking doesn't feel cold. If you define the system of the pork to be the system, that it's cooking and it's the endothermic process. So, with all that said and done, I'm going to walk back in the rain, and until next time, everyone, stay safe, and unlike these sheep, don't catch on fire.